In the skies over Japan, the cockpit crew of a Boeing 747 is struggling to control the massive airliner after a huge bang was heard. On board are 509 passengers, most of them Japanese nationals. For over 30 minutes, the airplane wanders through the Japanese airspace on a seemingly random track around Tokyo as the pilots struggle to regain control before the plane eventually crashes into a hillside. This is the deadliest single aircraft crash in aviation history. Let's find out today how it happened. Subscribe so you won't miss any future aviation videos. Welcome to Airspace. On August 12, 1985, Japan Airlines Flight 123 boarded its 509 passengers for the domestic flight from Haneda to Itami, Japan. The traditional holiday of Obon was around the corner, and many passengers were trying to get home to their families. At 6:12 p.m., the plane departed Haneda. Just 12 minutes later, as the plane was climbing through 24,000 feet, a loud bang was heard and the cabin pressure dropped. The crew declared emergency and requested to return to Haneda Airport. Their request was granted and the air traffic controller ordered the plane to turn right. The first officer was in control at the time and complied, and started turning the plane. Quickly, the bank angle became greater and greater, stabilizing at 40 degrees. Normal turns are usually flown at a maximum of 30 degrees. The captain quickly intervened and told the first officer not to overdo it. The first officer responded that he was not, and that he could not control the bank angle anymore. Confusion arose, but quickly the flight engineer, who was present as the third man on the flight deck, realized that hydraulic pressure was dropping on all systems at once. This is such a remote occurrence that it almost borders on impossibility, but the crew of Japan Airlines 123 faced exactly that, a quadruple hydraulic failure. Now, the pilots tried to descend the aircraft, but it did not respond. Additionally, the crew were starting to feel the disorienting effect of hypoxia, which is a lack of oxygen. The captain required numerous attempts to comprehend that all hydraulics had been lost. It must have been terrible for the pilots to realize that they could no longer control the plane. Part of the reason for this uncontrollability could be witnessed from the ground, as this picture, taken by an amateur photographer, shows. The vertical stabilizer holding the rudder of the plane was missing. Without it, the plane started a motion called a Dutch roll. This is a motion in which the plane banks and yaws through the air in a side-to-side motion, like a snowboarder traveling down a halfpipe. Since the plane also lost all hydraulic pressure, there was no way of counteracting these forces. The plane also took up another motion, during which it alternatingly climbed and descended. This is the natural motion for uncontrolled aircraft. As it descends, it picks up speed and more lift is generated. The nose lifts up and speed decays, so does lift, and the nose drops again, finishing the cycle. While all of this was happening, the pilots attempted again and again to control the stricken plane, but to no avail. At one point, they had the idea of countering the climbing and descending motion with thrust changes on the engines. This worked quite well, but the crew was unable to counter the Dutch roll effect, since the large engines did not respond quickly enough. The investigation concluded that this would have been impossible anyway. At some point during the flight, the oscillations became severe, exceeding 50 degrees of bank in cycles of 12 seconds. They must have felt like a leaf in the wind. As the pilots later stabilized the plane at least somewhat, they had the idea of lowering the landing gear to reduce speed and dampen the up and down motion. This was successful, but the plane started to descend in a right turn, since the amount of thrust selected on engine 1 was greater than on the others. Now, in thicker air, the pilots were able to grasp what was happening, and the captain sternly remarked, "This may be hopeless," as the plane again started to turn to the left on its own, directly towards a mountain range. As the plane descended towards the mountains, the captain ordered the engines to full power in an attempt to pitch the aircraft up to lift them over the mountain range. Their success was limited and the thrust was reduced to idle again. This greatly aggravated the up and down motion of the plane, and the aircraft reached an attitude of 40 degrees nose up and stalled. Quickly, the captain ordered full power and the plane again entered an unsteady climb. The next idea the crew had was to extend the flaps. These are usually also operated hydraulically, but have an electric backup system. So they extended the flaps step by step. Slowly, the aircraft started banking to the right once more. As the crew extended the flaps more and more, the bank angle increased beyond 60 degrees and the nose began to drop. Now, the crew struggled to coordinate retracting the flaps again and adding and removing thrust, but it was too late. The aircraft had become completely uncontrollable and descended into the mountains while the engines were pushed into full power in a last desperate attempt to climb. The last thing the captain remarked was, "Well, we can't do anything now." In the last moments before the crash, the plane was almost level and ceased descending and hit the ground at relatively low vertical impact forces of 3G. However, the plane was still flying at almost half the speed of sound with a bank angle of 40 degrees. This created deadly forces on impact. The aircraft flipped on its back and exploded. After the crash, helicopters were sent to the crash site. However, the weather was bad and night was falling, and the helicopter crew of one rescue helicopter decided that there seemed to be no survivors. Instead of sending rescuers, the focus was set on establishing a forward base about 40 miles away from the crash site. In the morning after, first rescuers reached the crash site, where they found only 4 of the 524 souls on board alive. Many had tragically died during the night and could have been saved had help come earlier. Investigators were keen on finding the reason for this deadliest single aircraft crash in aviation history. After the wreckage was recovered, it was reassembled in a hangar as well as possible. In the end, the committee found the culprit for the accident. In fact, the accident had been in the making for the last 7 years. In 1978, a rather inexperienced crew landed the 747 hard and flared the aircraft excessively during the maneuver. The tail contacted the ground so violently that the rear pressure bulkhead of the aircraft cracked. This bulkhead is like the lid on the pressurized can that is the passenger cabin. After it was severely damaged, Boeing mechanics repaired it and the aircraft was released back to service. What went unnoticed until Flight 123's crash 7 years later was the fact that the repair had not been carried out correctly. Instead of repairing the major crack in the bulkhead with a twin double row of rivets, the bulkhead was repaired with one twin and one single line of rivets, leaving a weak link at the single rivet line. When the passenger cabin is pressurized, stress is put on the row of rivets and the metal concerned stretches ever so slightly, leading to metal fatigue over time, sort of like if you bend a paper clip many times. In the end, the clip will break. The same unfortunately happened with the pressure bulkhead. After 7 years and 12,318 cycles, the metal cracked open and cabin pressure was released violently into the unpressurized part of the airplane's tail. Parts of the cabin ceiling were ripped out too. This explosive release of air and material ripped through all hydraulic lines that are installed in the tail and blew off the vertical stabilizer holding the rudder. From that moment on, the plane was doomed. It is amazing that it stayed airborne for another 32 minutes. In the aftermath of the crash, the Japan Airlines maintenance manager and an engineer that cleared the aircraft to be airworthy committed suicide. The captain's daughter went on to become a flight attendant. And there is now a memorial at the crash site, honoring the 520 people who died in that accident. After the crash, Dennis Fitch, a United Airlines training check captain, learned of the accident of Japan Airlines 123 and wondered if one could successfully fly an airliner that had lost all hydraulics. He tried various procedures in a simulator. By some very strange coincidence, he would later be on United Airlines Flight 232, the plane that lost all hydraulics when an engine exploded. He was flying as a passenger. When he realized what was happening, he rushed to the cockpit and assisted the pilots with his knowledge, and they even managed to land the airliner without any hydraulics, just using differential thrust on the remaining engines. Unfortunately, the airliner crashed after touchdown, but about 60% of the passengers survived. I'll make a separate video on that case someday. I hope you liked this week's video. Make sure to subscribe so you don't miss any future episodes. See you next week.